Welcome! Today we're diving into how artificial intelligence is completely changing the blueprint for data centers. The huge AI workloads, especially for training complex models and running real-time inference, are pushing traditional data centers beyond their limits. They simply weren't built for the kind of power, cooling, and networking AI demands. So, what's changing? First, the compute itself. AI, particularly deep learning, thrives on parallel processing. This means a huge shift away from relying solely on CPUs. Now the stars are graphics processing units, or GPUs. They are much better at the complex math needed for AI. We're also seeing more specialized hardware like TPUs and NPUs, designed specifically for AI tasks, boosting efficiency even further. This specialized hardware is power-hungry. AI gear, especially clusters packed with GPUs, uses vastly more electricity than older systems. Rack power density has jumped from maybe 15 kilowatts to well over 40, even hitting 100 kilowatts or more. This surge demands serious upgrades. Data centers need beefier power delivery systems, often using higher voltages. And all that power generates incredible heat. Traditional air cooling often can't keep up, making advanced liquid cooling solutions essential, whether it's cooling plates right on the chips or even submerging hardware in special fluids. AI also means moving massive amounts of data. For training AI models, you need extremely fast connections between the servers in the cluster. Think of GPUs constantly sharing huge datasets. This requires high-speed links, like 400 or 800 gigabit Ethernet or InfiniBand, and smart network designs to avoid traffic jams. For inference, using the trained AI models, the focus shifts slightly. While still needing speed, the priority is often low-latency communication between users or applications and the data center. This often involves edge data centers, located closer to users. And where does all the data live? AI needs fast, scalable storage systems that can feed enormous datasets to the training process and quickly serve data for inference. Think high-speed distributed file systems and object storage capable of growing as data piles up. How are data centers adapting architecturally? We're seeing purpose-built AI factories, massive facilities designed from scratch for AI. Modular designs using prefabricated units are also popular for speed and flexibility. Many use a hybrid approach, mixing cloud resources with their own infrastructure. And interestingly, when choosing sites for new AI data centers, cheap, abundant power, often renewable, is becoming a top priority, sometimes more important than being close to major cities, especially for training hubs. It's worth noting the subtle differences in infrastructure needs. Training focuses on maximum compute power, massive internal bandwidth, and heavy-duty power and cooling. Inference prioritizes low-latency access and high throughput, often deployed more geographically distributed. In short, supporting large-scale AI isn't just an upgrade, it's a fundamental redesign of the data center. It requires specialized compute, much higher power and density, advanced cooling, super-fast networking tailored to specific needs, and scalable storage, all working together seamlessly. It's a whole new era for digital infrastructure. Thanks for tuning in.